So today, and maybe including the next class, we will study the variability. That means that the definition of variability, also what impacts the variability can have with the actual production system. So from now on, I'm going to use the note instead of this PowerPoint. So let's see our object when we have run the full contents of the variability. After we have run all the contents, I expect that all of you can analyze, it means calculate the performance indices with related these kinds of process. It means that there is a process, the preceding process, and the following process, and each process have its own the process parameters, such as the process time, also including the coefficient of variation, also the kinds of the breakdown, also process 2 have the same kinds of parameters. And from these parameters, also the considering together with the constant of variation of the arrival rate, arrival time, also the propagation of the variability with between each connected process. And eventually, I expect all of you can calculate how many number of the WIP area have to be secured in order to make this connected process is being processed seamlessly. It means that continuously without disruption. So anyway, this problem will be treated maybe at next class or next week. So today we will start from the very simple, the very basic of variability. Okay. Okay, we have to start with what is variability. Its definition is like this: quality of non-uniformity of a class of is the kinds of the homogeneous system. So this variability is very closely related with randomness. So that's the reason why That is the reason why the probabilistic or stochastic approach is required. So in previous chapter, we have studied the worst case and practical worst case. And these two cases is different from the best case. This case cause a low level of system performance. Among these two cases, only worst case predicted perfectly with the formula that we have learned. However, practical worst case is caused by the unpredictable randomness. So the variability that we are going to learn is closely related with the practical worst case if we compare the model of PennyFab1. Now we have to configure about the kinds of variability. There is two kinds of variability. First is controllable one, and the other is the uncontrollable one. Controllable variability is such kinds of things. For example, product mix or kinds of batch production. Product mix can be defined with the will of the production manager. So this variability can be controlled by the human or by the personnel. Also, in case of batch production means that the type of production that the defined size of group is being moved together. So this number of product that is those are belonging to any batch can be defined in advance before the production. So these kinds of the variability can be controlled. So product mix or batch production, they have impact on the variability. However, those numbers is being defined previously. So it is wholly controllable. So this controllable variability is not our object of this class. Our object is the variability that is, those are uncontrollable. The kinds of uncontrollable ones is for example, the customer customer order, or the breakdown, or some kinds of machine error. These kinds of factors are not controllable. For example, customer order cannot be controlled by any managing activities of the company. Customer order is only dependent on the external side of the company. Also, if we look into the factory, any kinds of breakdown or power outage or the machine malfunctions are not controllable. Also, any kinds of minor error, even though the level of microseconds or micromillimeters, those kinds of variations are not controllable. So our target in terms of variability is belonging to this uncontrollable and mainly related with these things, breakdown or machine errors. Only the exception there is the machine setup. The machine setup is the activities that is required to make some installation before the starting of any production. This setup is belonging to the controllable area. However, we will treat this one, the impact by the setup activities will be treated in terms of variability aspect. Next, we are going to the survey some basic level of the problem intuition. Here we will see the concept of moment that is borrowed from any physics. First moment is one of our first moment example is the average. Let's see some example. We can, if there is problem of insufficient throughput in any factory, and the factory manager wants to increase the throughput, then what can the manager can do in order to increase the throughput? From the Little's law, throughput is related with these two performance index. So if we fix this level of WIP, then we can change or improve the cycle time in order to increase the throughput. It means that if we want to increase the throughput, then we have to decrease the cycle time. It means that, or the same thing with the cycle time decrease is that increase the capacity. It's the same meaning. Anyway, in this example, if we are going to increase the throughput, then with the intuition of first moment, we can upgrade this system by increasing the production capacity. For example, speeding up the machines. So this kinds of intuition is very easy and very intuitive by human brain. This kinds of intuition is called first moment. And most humans are very familiar with this first moment intuition, and mostly related with the concept of average. However, let's see the second moment. By referring several kinds of the example. Okay. Okay, can you think which is more variable? It means that which have the bigger variability between time to an individual part, respectively, compared to the time to process any number of batch of parts. Which is more variable? Can you think, or can you think intuitively? Let's see next one. Which is more destructive between short and frequent failure and long and which is more disruptive, or which is the worst? Can you think intuitively? Short and frequent failure or long and infrequent failure? Maybe it is not easy to think intuitively this kinds of example. These questions are rated with the variability. And in this case, we need more sophisticated intuition in order to answer these questions. So we are going to concentrate on the second moment of the production system in order to answer these kinds of questions. So now we need to study variability in terms of theoretical forms. Okay, this is the lunch time. So from now on, we will continue at Wednesday. And at Wednesday, we will use the same manner by drawing and by writing with this note. Okay, let's see again at Wednesday, and we'll continue this variability with the mathematical forms. Okay, and let's have the Q&A in next class because I have another meeting after this.